Integration of exponential functions and derivatives of log functions. One result of knowing this derivative is knowing this antiderivative. Notice that the derivative of a to the x is log a times a to the x. Now the antiderivative of a to the x, you still get a to the x, but now it's 1 over log a. Let's use this rule to do a problem. Have u be x squared, then du equals 2x dx. And so x times dx would be 1/2 of du. Do your substitution. Instead of x squared, put in u. Instead of x times dx, put in 1/2 of a du. Then integrate. Use your integration rule and then substitute back. Let's do another problem. Have u be the exponent, negative radical x. In that case, du would be negative 1/2 times 1 over radical x dx. Again, I can see that I've got 1 over radical x dx. I have what I need. So what I'm going to do is just solve for 1 over radical x dx, and I get negative 2 du. Now let's work on the bounds. If x equals 1, u equals negative 1. If x equals 4, u equals negative 2. Let's do the substitution. Instead of negative radical x, I put in u. Instead of 1 over radical x dx, I put in negative 2 du. Instead of the lower bound of 1, I put in negative 1. Instead of the upper bound 4, I put in negative 2. Now, since I've changed the bounds, when I integrate, I will not substitute back. So at this point, we just want to find the antiderivative. So we find the antiderivative, and then we evaluate it. Now, 6 to the negative 2, that's 1 over 6 squared. And 6 to the negative 1, that's 1 over 6. Also notice that I have a double negative. And I'm going to also pull out that 1 over log 6. So when the dust settles, this is what I get. And then I just simplify that. And I get 5 over the product 18 times log 6. Now, in the previous section, we learned that the derivative of log x is 1 over x. What if you have a different base? What is the derivative of log x base b? Well, it's still 1 over x, but now in the denominator you have log b. And this can be extended to the chain rule. So the derivative of log u is u prime over u. That's the same. But now if your base is different than e, if your base is b, then you have to have in the denominator log b. Now if b is equal to e, then log e equals 1, and there's not a problem. It's completely consistent. Let's find this derivative. So it's going to be u prime over u, and in the denominator now we'll have log 5. Now notice that that's natural log of 5, ln of 5. So ln of 5 in the denominator, and 2x plus 1 in the denominator, and then in the numerator we put the derivative of 2x plus 1. And the derivative of 2x plus 1 is just 2. So we're all done. Let's find the derivative of this function. Before finding the derivative, you want to rewrite it as something to the negative 1 power. That way we can use the power rule. So the power rule, we're going to bring down that negative 1, and then it'll be that expression to the negative 1 minus 1, and then times the derivative of what's inside. So bring down the negative 1, and then log x base 6 to the negative 2, and then times the derivative of log x base 6. Now the derivative of log x base 6, what's that equal to? That's equal to 1 over log 6 times x. We need to simplify this. First, let's use the change of base formula. After we use the change of base formula, let's use the property that a over b to a negative power is b over a now to a positive power. It's a nice little trick, isn't it? So after we do that, let's see, what else can we do? Now let's use the rule that b over a, quantity squared, is b squared over a squared. Once we do that, we can see there's a cancellation we can do. So when the dust settles, we get log 6 over x times log x being squared. And then notice that the whole thing is negative. And that completes this section. I'll see you again in the next section. Take care and have a great day.